So I've owned the HAAS ST-30Y lathe for a period of 1 year. And in this video, I'm going to show you how we tooled it up, how we set it up, including the bar feeder, and answer two critical questions. Number one, does it hold advertised tolerances? And number two, was it worth it? Let's get started. So we're talking about the ST-30Y lathe from HAAS Automation today. And as a reminder, I purchased this machine to increase our capacity for our turned components. And even some of those components that could easily come off a mill, we're gonna move that over onto this lathe because it does have Y travel, live tooling, and dual spindles. So that's a nice thing. We've actually made parts that you probably wouldn't think were made on a lathe, but we've moved them over here just to take the excess burden off of the mills for simple, low dollar, low tolerance components. So when I purchased this, my only frame of reference was the two Doosan lathes we have, which are fantastic, well-built machines. This was one of those things where it was a newer machine. This is an ST-30Y reboot. It kind of competes with the DS-30, which is a dual spindle, very much larger machine. This lathe in particular is just a little bit more compact, but compared to our Doosan with the same setup, BMT 45, this is BMT 65, the next, or actually two steps up in BMT tooling. And it's just, I like the larger size. I gotta say, setups with the Doosan, just because it's a more compact working envelope, it gets a little nervous. Here, we know that if the sub spindle is jogged all the way forward and we accidentally or unintentionally, or we just didn't realize that the turret is going to rotate to a different tool, it has plenty of clearance. Now, the live tool Doosan we have has safety zones where to get down close to the workpiece, you have to override it saying, hey, this is a zone where it might crash. It's okay to cross over. I proofed out the program. As far as I can tell, the HAAS does not have that capability, but really I haven't missed it because none of the sheet metal, none of the housings, none of that stuff even comes close to colliding. Like you have to watch out for some of that on the Doosan. So that's one thing I really like. Let me get you a closer look and show you how we tooled it up. Okay, so the machine itself came with a lot of these tool holders. We used most of them. We did buy a few more from Command Tooling Systems. I'll show you those in a second. But what I really liked was these Benz live tool holders. That's kind of like the standard issue. I think the Doosan came with Exis Eppinger brand. So far, I like these better. They're cool, they're quiet. I don't know if that's a combination of the gearing or the motor, but I prefer these over the Eppinger. And these are also, I think they're from Germany, so really high quality. Let me rotate it, I'll show you the rest of the tools. Okay, we did buy 3 extra tool holders because they were in a configuration that just didn't come with the machine. So the first 2 are Command because they hold both direction to mill on the main and the sub. This is our CNMG and our VNMG held at a 45-degree angle. These were from Command. If I remember correctly, $700 or $800 a piece. And we've pretty much tooled it up 100% with tooling from Kyocera, pretty much my favorite new tooling company. Fantastic product offering and great service. Really happy with them. This particular CNMG tool holder delivers cutting fluid right to the face of the insert through the clamp. Absolutely love it. It's given us fantastic performance. But this one is a star of the show. This is from Lindex Nikken and it holds 6 tools. The beauty of this is, and you can only do this on a lathe that has Y capabilities, is you can have, like this is tool block 3. We have one tool here, which is T303, T313, tool 323, and then we flip over and we go 353, 363, 373 that are sub-facing. So you get a lot of bang for your buck out of this $1,000 tool holder. And it's great because you can dial in not just your center line of X, but also in Y, so you know your drills are spinning true right on center. That's really important. A lot of times if some of these holders are not made right, or maybe the turret's been bumped, you need to shim it. It's just a total pain. That's a nice thing. Probably the most useful thing that I've experienced with a Y capability is you can dial it in so it's absolutely on center. Fantastic thing. And finally, speaking of tooling, we also bought a probe. Now it's not in here. Why? We're just not there yet. So I bought the probe, not so much for cutting down your time in setups, but for checking dimensions on parts, making sure that parts are actually being cut. And that way we can run this in a lights out application, unattended. Kind of the strategy is, once we move to full lights out machining, we will cut parts using a far more conservative tool program that has the tool probe that comes out to check for break detection, wear on the inserts, as well as to check dimensions with this. Now, the thing is that you typically don't want to inspect parts on the same machine that it's cut on, because if there's some type of thermal growth, well, it doesn't know that. It just thinks it's on center, although the OD might be totally off. But this at least keeps us in the ballpark, knowing that we've actually taken a cut that was supposed to be taken. So with that being said, let me walk you through a setup, including the HAAS Servo Bar Feeder, probably my most favorite part of this machine. Let's take a closer look. So one of the things I've really learned to love is the Servo Bar Feeder that I bought with this machine. Let me just give you a quick walkthrough, because I couldn't find that much information just on other YouTube channels. The HAAS channel had a complete walkthrough. I'll give you a quick overview. So when you go to current commands, there's a bar feeder screen, and you just enter some basic information. Length of the longest bar, which we cut all our bars to 48 inches, 4 feet, and then we load them in. That's the maximum length. You can also put in a 2 foot, a 30-inch bar, a 12-inch bar. You can mix and match. You just need to tell it that the longest bar that it will see is 48 inches. Next is the push length, which is actually it tells you right here, the push length is the cutoff width. So we use about an 1/8 inch wide cutoff parting tool, the actual part length, and then the facing allowance. So when you total up the face, the part length, and the width of the cutoff tool, that's what you put in. Here it's 700 thousandths. Then the initial push length. I'll show you that in a minute with some footage, but basically how far from the face of the chuck do you want it to push to begin cutting? And then the minimum clamping length. When you get to the end of the bar, how much should the collet actually hold before it switches to a new bar? In this instance, I'm holding on just 1.5 inches. That's plenty. And then finally, the parts counter. You can set it to 0 and it's just gonna run. You could, an operator could load more bars. But in this, we did a product run of 1,000 pieces, so we have 1,000 in there. From there, you just walk through, and it is very logical. It just tells you setup 1, load and measure bar. I don't have anything in there, so let me walk over there and get the hardware set up right now. All right, the first step is to actually move the bar feeder completely out of the way so that you have access to the feeding tube. And from here, there's just some spindle liners. Now you put in this default larger spindle liner that goes in, and then that serves as an adapter for the smaller one. So here's my 1-inch spindle liner. And so you have a liner in the machine drop tube. And then you have this, it just goes on the end, and it has a large spring. That's it. So you need spindle liners because you don't want that bar whipping in the bore. So once I do that, pull it back, gas springs, slow it to a stop, really nice touch. Now we need to push that. You have 2 push rods, I believe they're called. This is about 3/8 and this is 3/4. So since we're using 1-inch material, I will use the 3/4 inch push rod. has a bushing here. Snap that in, and then on the tail end here, so that's appropriately loaded. Let me grab the material. And I'll just put 2 bars again, cut to 48 inches. They want it as close as possible to the bulkhead, just some consistent length, but honestly, if they're loaded a little bit left to right, it's not a big deal. Ideally, this stays closed. During production, you load bars from the backside just to keep the machine running. So that's all we need to do for now. Let me go back to the machine. It asks us to step through some things conversationally, including adjusting the height of this. And yeah, let's just walk through it. Okay, so it is asking us, step 1, load and measure the bar by pressing F2. We do that, machine powers up. Okay, that's loaded, so now it's asking us to adjust the transfer tray height. Let's step back over and do that. Okay, so we did that. Step 3, F3 to advance the bar. I see the bar loading. Okay, now it's asking us to jog the bar into place. So we do that by entering handle jog, which it tells us to do. Open the chuck and jog it forward. Now, the bar needs to be flush with the face of the chuck. Usually takes a couple times to do this. Perfect. And now, once we've done that, we hit F4 to set the reference position, meaning that's the bar in line with the face of the collet is essentially a bar feeder Z0. So we're gonna do that, and it says, would you like to advance the bar to the initial length of 2.5 inches? Simply hit Y for yes, starts coming out, clamps, resets it, setup completed. So it's that easy. Now, once I have my program running, it's just gonna continue to run, always advancing to 2.5 inches. It parts it, advances it 700 thousandths, continues. When it has less than 1.5 inches clamped in the chuck, it's going to spit it out, load a new bar. Pretty straightforward. So the bar feeder has been programmed. We've loaded tools. I've proofed out the program. Let's make some chips. So what are my final thoughts after 1 year of owning it? Well, I can happily say that we are all very pleased and satisfied with this machine. So it was initially purchased to do higher quantity runs just for certain times of the year so that we would take 1 month and run one component so we had a year's worth of inventory. It also was purchased with the thought that maybe we don't put the critical tolerance parts on this and just run the standard plus or minus 5 thou, and then just run that through bar and also take some of the burden off of our mills. And we've been doing lots of 3-axis milling. And so that's the purpose that we purchased it for, and I'm here to say that it's been fantastic. I really like it. It's not without some hiccups though. For example, the bar feeder had some little bugs in it. The HAAS factory was quick to fix it. We had some spindle things. It turned out it was a programming issue on our side because we were approaching it with the mentality that it read the exact same G code and M code from a mill. There were some things that you had to break up. I'm not going to get into the nuances of that because, quite frankly, I don't understand them all. I just know that we just needed to break up certain longer strings of G codes. We know that you can't put multiple M codes on a line in a mill. The lathe, from what I understand, is some G codes aren't compatible on the same line. So it's little things that we just had to get used to. One of the things that I really liked is the familiarity of the HAAS control and how easy of a transition it was going from the mill to the lathe. Now, I'll also say that the bar feeder was a really easy integration, as you saw. One control, one manufacturer, communication is just seamless. The only issues that we had was kind of like you have to change the pitch of the ramp because sometimes a heavy bar coming down a steep ramp will pop up the next bar. It's all these little things that you just get used to with any brand or any model of machine. You find out how it works, how all the quirks it has, and you record that and you make adjustments accordingly. So a few things that came with the machine that I initially liked, but in retrospect, I'm not sure it was totally worth it. The auto door, kind of not used at all. Why? Because we do long run productions on this. So the door is closed all the time. Now, on the flip side, usually I buy mist collectors for all my machines. I'm probably not going to do that on this one because, again, the door stays closed all the time. We don't want that airflow further evaporating the coolant or pulling out any mist from the machining enclosure because we're just going to get rid of coolant that way. Some of our machines burn like 10, sometimes up to 20 gallons a day of coolant when we're taking hot cuts and it's a hot day. So with this machine, no mist extraction, keeping the door closed, it's great. It works perfectly. We really like it. Now, a common question I get is, does it hold tolerances? Now, I did another video called HAAS versus Doosan, where we talked about the Doosan and HAAS and the pros and cons between just those two brands, namely because we own Doosan lathes and this is our first HAAS lathe. And in the next Pierson Workholding Q&A, we are going to go in depth now that we have a true apples to apples comparison of the HAAS versus Doosan lathes. So look for the description below. That's where we're going to put it, or the comments. But until then, I'll tell you that this machine was surprisingly, like I say surprisingly because I thought it's going to be a general purpose mid-range tolerance machine. I was happily surprised that this machine will hold plus or minus 1 thou out of the box. Now that was surprising to me because it is a big machine. There's lots of casting, moving parts. All those, the more mass you have, the more distance between components, the more thermal variations you'll see. So we would come in on a cold morning. Now keep in mind, we're in Southern California, so we don't have large temperature fluctuations. We never get below freezing here. And even if we did like a day in the 30s in the middle of winter, inside it's probably gonna get around maybe 55, 50 to 60 degrees, that's normal. On a hot summer day, we'll kick on the AC and the most amount of, I guess the highest heat that we'll see around here is in the low 80s. And so we have a fairly narrow thermal window, but I gotta tell you, I was so happily impressed that we would see sub 1 thou movement on parts. Now, the other thing that we learned just recently when a technician was coming out, he said that, well, he was here in the morning and my lathe operator, Chris, was chasing the first probably 40 minutes. That's where you see the most amount of thermal variation. So a part may be off by 1 thou, and then the next part's just a few tenths and it creeps up. And he said, oh, you should use thermal compensation. And I'd never heard of it. Chris had never heard of it. And so in the HAAS control, what you do is from the day before when we are machining parts and they are right at 0, You come in the next morning and then you take a measurement and say it's off. Let's give it an exaggerated delta of maybe 2 thousandths off. The first part is 2 thou underside. What you do is you plug into the control the axis, and like for example, if it's the x-axis, that's 2 thou out of tolerance, you say 2 thou. Chris knows that within the first 45 minutes to 60 minutes, it gets right back on 0. So you just tell it, thermally compensate in a linear graph, in a linear way, I don't know how to even say that, but go from 2 thou and within 60 minutes incrementally change the position of your cutting tool back to 0 over 1 hour. And so this allowed us to come in, and when we turn on the machine, it says, would you like to apply thermal compensation? Yes, we would. The first part would come out, it would be pretty close, tenths off, and over the next 60 minutes or whatever time we put in there, it would thermally compensate to keep those initial parts within spec. So this did 2 things. Number 1, we're not scrapping a bunch of parts. Some shops scrap the first 30, 40 minutes of obviously a low dollar part. They just throw them away. And we don't do that. We have actual usable parts right off the bat. Second thing it does is it causes my guy, Chris, to not have to stand here and after each part change offsets. So a lean win in my book. So what about some cons? Are there things that bug us? Yeah, like quite frankly, I don't like the parts catcher. It's not as gentle on parts. I'm gonna talk about that in the Pierson Workholding Q&A where we take these 2 machines, this and the Doosan, and go head to head. But I don't like how basic it is. We've had to pad and line our chute at times when we have parts that do have critical surface finishes. We're running parts right now that we don't want them colliding into each other. And so we're having to essentially tend it. I know there's different products out there like a Royal Roto Rack. That's something I might add to this that takes parts off as an accumulator. But overall, the question is, am I happy with this purchase? Would I keep the machine? Would I buy it again? The answer is yes. I absolutely would buy one of these machines. It's a loud machine. We don't like how loud it is. HAAS has been really receptive to the things we don't like. Hopefully that benefits any of you who are considering HAAS lathes, that they will roll out that feedback that we gave to the factory and make a better product. That's all we can ask for. Overall, yeah, this is especially the ST-30Y is just a production beast where we can load up bars in the bar feeder, confidently walk away, and we have good parts. That's why we bought it. I'd definitely buy it again. So those are my thoughts. If you're interested in this, I'll put a card right here to my first HAAS versus Doosan. Make sure you subscribe so that you can catch the next HAAS versus Doosan head-to-head comparison. And until next time, go innovate your production.